Hello, I'm Matthew Mendoza, and this is my video tutorial for my final project for the ME5711 Fundamentals of Robotics course. So, I based my design off of the Guardian XO full-body exoskeleton prototype from Sarcos Robotics. You can see the final version here and the prototype here. And in this video here is a short clip of a person lifting a box using the exoskeleton, and this sort of movement is what we're going to be modeling in MSC Atoms. So on this slide here is my final video thing that I made within Atoms, the simulation. You can see it here, bending over to pick up a box. It's going to lift it off of this lower shelf, put it on the upper shelf, and then return to its neutral position, the starting position. So again, as you can see, there's no person here. I just modeled the exoskeleton itself, or the robot design, and its joint movements as it performed this task. So as it does that, I'm going to show you how I did this, starting in SolidWorks. So here we are in SolidWorks. You can see here I have my full assembly of the robot body, as well as the shelf and the box. It's important to have everything you want to go together in one big assembly. Like even though this is a smaller assembly here, this robot body, and the shelf and box is its own assembly. This is because when you bring it into Atoms, it's going to keep all these orientations you have, such as like how far away these are, or how this box is centered on here. And if you want to bring it in separately, like just the robot body or just the shelf, you can. It's just going to take quite a while to reorient everything because you have to move it around using Atoms, and it's not the same as moving it in SolidWorks. Another thing is to make sure that there's no parts with the same name. So like you can see here, I have them all differently labeled, like the foot right here and the foot left here, even though they're kind of the same part, or even here, like the thigh. Yeah, thigh right and thigh left here. I have them as different parts just because if you bring in two parts from SolidWorks with the same name, Atoms is going to treat them as one file, and it's going to be a pain to kind of move them around. So that's a big one. Make sure they're all different. Make sure they're all in one big assembly. And once that's done, all you have to do is go to File, Save As, and then let's just put it here in SolidWorks Import. So you want to save it as a Parasolid file right here, and just name it whatever. So in this case, we'll do Project Import, for example. Oops, spelled there. So once that's done, it should be good to go in Atoms. Okay, so now that we have Atoms ready here, just want to go to New Model. We can name it, let's see, Final Project Test or something like that. You have to keep underscore. Atoms doesn't like when you put space between things. I didn't have gravity for this, you can just turn it off there. And in the working directory, I'm just going to pick a folder for video here. That's just what I set up for this. So, now that's done. I want to go to File, Import. And for the file type, you want to just choose Parasolid. That's just what we made in SolidWorks. And for the file to read, we go to SolidWorks Imports. It's going to be Project Import here that I made. And then for the model name, you want to just pick Final Project Test. That's just the name of this thing that we made, the database we made in Atoms. So, and then there we go. By the way, quickly, you can press R and then move your mouse with a click. Same thing with T to translate, and then Z to zoom. It's just going to be useful for later on when you're labeling things and doing the animations and such. So in this wireframe mode, you want to just click this little ball here, bottom right, and you're ready to go. So first things first, before you do anything, you're going to want to give everything material. We're just going to be pretty easy to do. So it's going to be right-click. This is all the bodies from SolidWorks. Important thing to note is that Atoms, the student edition, as you can see with this hat here, it only has a maximum of 20 bodies. So keep that in mind when you're making your model. It's going to treat everything individually, like I said, like this, the box, the shelf, the hands of the robot, and all that, including the ground as well. But anyway, yeah. Back to this, we're going to go to box here, for example, modify, and then mass properties here, and geometry density, excuse me, geometry material type. Just double click here, and then it'll give you aluminum. Let's do that, and then hit OK. So it's a little bit repetitive, but we have to do this for all of these, just because it'll give Atoms something to simulate once we do the animations and such. So I'm gonna go ahead and cut to when I'm done here, so you don't see me clicking like a billion times. When you're done setting up all the material stuff, like I am here, you can see this last one, like Project Cast Aluminum. You want to go into the joints, so that's going to be under here, the top menu here. I already have it open because I set it up for the right side here, as you can see, but we're going to be doing the left side. So first we want to lock things down. This is in the case you have gravity, or if you don't want things to move relative to other joints. So in this case, I don't want the feet to move or the shelf to move. So first thing here is the fixed joint. Make sure it's here, one location. And you want to just click on the area that you want to be locked. I just click the bottom here. This should lock the entire foot anyway, but that's just where you want to click. The next here, just want to lock the shelf here. There you go. This just means it's not going to move. Any new things you make as connectors under the connectors folder here. So this, again, this is just stuff that I've done early ahead of time. But it's good to rename them like I have here, just to make it clear, especially when you're choosing them for your motions here. We'll do in a bit once we're done with this. So this is just a lock joint, so it doesn't really matter, but I'm going to go ahead and name it like I did the other one. So put a dot first for these names. Foot underscore lock underscore L in this case. And this one's just a shelf, so we're just going to name it, say, shelf lock. Oh, oops, misspelled there again. There you go. Alright. Now that's done, we're going to go ahead and do the joints here between the connectors here, sorry, between the joints of the robot. This is telling items how it wants them to move. For this, I recommend you going here back to wireframe. Now we can click in the middle part here, and the middle where they're kind of connecting against each other. So that's the proper place it is. Notice that when I first did it, and I did it on the side or something, Adams would give me an error when I went to the motion. So you want to make sure this is correct. So this is the same thing as before with the locked joint, fixed joint. Here, create a revolute joint. So I might have to zoom out a little bit to see it. If you hover over it, you'll see a little thing like there, test bot foot left. Like start here and then go up here, ankle left, and then not there, here. See, in the middle there, you can see. So it's kind of facing the wrong way. You can see relative to that one. So to do that real quickly, you want to go to right click here, modify this, change position here. I believe this sets at 30. I have it set to 90 because I already edited these. But this just tells you how you want to rotate it, so click that once. Boom, it's facing the right way. Also forgot to rename it. So this was foot 2 ankle L. Okay, so do it again real quickly here for the knee, as I named it there. Sorry for a second here, just trying to line it up. There we go. Sometimes you just kind of have to move around a bit to get the correct location here. There we go. Okay, same thing. Revolute, ankle, thigh. You have to move your cursor around again. It's not always exact, but make sure it's in this part here. Center. And then modify. So I'm going to do Y here and then X, so it's downward like this, because that's the way you want it to bend. Put a knee, of course. And we're going to go ahead and name this L. Perfect. Next up, center here. Yep, that's correct. You can also hit escape to get out of that menu immediately, because it likes to assign multiples at a time, but just in case, you can just do that. So this is thigh to body L. Again, it's facing the wrong way, so you want to just go to modify and then flip it this way. Perfect. It's a bit tricky, but we'll see if we can get it here first try. Nice to zoom in again. Connectors, revolute joint, body, arm upper left, and the center here. Okay, that's good. Named it shoulder there, so then we're gonna modify, flip it twice. Next is this thing here. Upper left, lower left, and the center here. Ooh, I actually misclicked that. Yeah, see? So you have to kind of be careful here. So that's fine, you can just delete it. Okay, so that's in the right location now. This one's just going to be same as the other side, so that's arm L. Okay. This one's another one. Oops. Oh, so it doesn't like the body here. Sometimes you maybe have to zoom out a little bit to get a better click on it. Not that. Maybe here might be better. Oh, appeared for a second. Lower left, hand left, and the center here. Make sure it's in that location. It is. And then, oops, put a dot first. Arm, 2, hand, L. So that's done. Again, I already did it for the other side, but if you're doing this from scratch and following me along, you would have to do that side as well. But it's the same thing. So that would be the joints. And now we're going to move on to the motions itself. Okay, so now that we're on to the motions, you first want to start by going to forces here, creating contact force. You're going to be doing this 3 times, one between the box and the shelf, and 2 here for each of the hands, so this hand in the box and this hand in the box. And so that when they make contact later, when the robot's lifting the box, it's actually going to touch it, and it's not going to go through it or anything like that. It's not going to punch it to the side. So to do this, showed here, so just go to forces, and then this is contact force. So it's going to have this dialog box can open up, so you want to double click here. So this is why it's good you label it. So you want to go to box here. I do the box first for the eye solid. So solid 15. Make sure you go with this solid and not the part. So same thing here. This is going to be the shelf. So solid 14 there. Okay, so again, these values aren't going to be wholly realistic, but it's just going to be what gets the simulation to go. So, excuse me, 100 there. This is going to be slightly increased to 11. And you're going to want to turn on friction forces here if it's not already on. I have it on by default, I think. But these are going to be staying the same. I'm just checking my notes here. Okay. So I can minimize this. The force that you made should be here. Again, I'm going to rename it so it's clearer when I'm doing some analysis in case anything goes wrong. So let's do box to, oops, shelf. Perfect. Okay, next. Then it's going to be, we'll do the right hand here. So start with the box for the eye solid, solid 15. And this one, I have it just as test spot hand, but this is the right hand for me. Probably should have been more specific, but anyway. So this one will be, sorry, just have my the values written down, so I'm just gonna copy them over from the other one. Okay, 100 here. It's gonna be up to 50, and the coolant force is also here, but these don't change. I'll rename this as well. To box 2 and R. Oops, capitalize that just in case. Last one. So, oops, don't want that. Solid 15, okay. Click here, hand left, solid 13. Okay, and then just like before, we're going to change these. 100, 50, and then this is going to be on again. So, now that's done, we're going to now assign the, sorry, I'm just going to move this here so it's straighter, the motions to these. So I have them all set up differently, but this is what I do here. So you want to go to motions here, rotational joint motion, and then you want to click on these. Because you've made these connectors earlier, it's going to only pick these, so you want to select the proper one here. So let's just do foot to ankle R here. That's what we have here. And then I have a little notepad here of the values from my initial one. just so that I wouldn't have to, manually type all these out again. So for this case, for example, just gonna shrink this a little bit. I have it labeled differently again, like ankle move R, but in this case, we're gonna go ahead and, whoops. Oh, sorry, this is the one from before. All right, let me just rename this then. Box and L. Okay, so this is done. The forces are done. Here's motion 1. So we're gonna rename this to. It says here ankle move R. So now to do this, you're gonna go to modify. It starts off with some time function, but what you want to do is you want to get rid of this because we're going to be using step functions here. You can highlight it here. So in this case, if you're stuck, this assisting will help you fill it out here. So it's defaulted to time, but in case it's blank, you can just type in time for this first box. In this case, so this is the first one, right? So begin at, this is this one here, 0, and at, it's here, 60, right? So 60. Initial function value is going to be 0 degrees, and the final function is going to be negative 30. So I guess it's kind of filled up from when I did a test earlier, but there it is. Okay. And then if you want to add more, all you have to do is hit a plus, and then. So I'm just going to copy these in because this will give me the final position and all the movements I'll need throughout it. So there. Okay. So and then OK here, so that saves. All right. Next up we have knee bend R. So that's going to be this thing here. Or in this case, knee R. Excuse me. Oh, that's another thing. I forgot. Make sure these are different names. I think Adams will warn you anyway if they're the same name, but I have it like knee bend, for example, or like ankle move, Same thing. So modify here. Don't want this. Copy these over here. Yeah, the first one you don't need a plus, but everything after it's just saying add this and then movements later on. Next up is the left side, which is the same, but knee L in this case. So I'm gonna fill this in here. And then just copy. I guess just for sanity's sake, I'll copy this one. These spaces, if there was any there. Okay, next up we have thigh move R. It is important to note that at least for the way I set it up, you only need to move one of the ankles here, and then instead of both of them, just because of how it's connected. So if this one turns the way the joints are, it's also going to turn. The knees are different because I need them to bend downward, and I think because of how the links are, so it's like 1, 2, 3, 1, 2, 3, 1, 2, 3. You need to assign them separately, but that's just how I did it. So anyway, so we're gonna go to thigh R, thigh to body R in this case. Thigh move, okay. In this case, thigh is the same because you only need one of them to make it work. Oops, I almost renamed it again. So this is this one. Making sure that's right. Okay. Next up we have, I believe it is shoulder move. Yep. So this here, we'll rename it. Oops, sorry. Modify it. Shoulder move L. Oops. Almost done here. So if arm move R, arm of L. Kind of did it in the other order, but that's okay. Alright, finally the last one is the hands. These ones move a lot, so there's quite a bit of them, but should still work. I'm just going to pre-assign this here, so it's easier. It'll also highlight it if you select it, so just in case, before you rename it, if you don't get confused. So the oh, yeah, see. Contains sortation wash name. Oh, my bad. I kind of just autopiloted there. Don't do that actually. Let's do hand. We go. Okay, so I'm going to modify this. And modify this. And that should be good. Okay, so with everything ready, you'll first want to go ahead and simulation here. I guess you could save just in case. I got here. So the end time is just how long it takes. As you saw there, ends at 1250 for me, and the steps is just 2000. This is just how fast it performs. You can increase or decrease these, depending on how slow or fast you want it to go. But here we go. Oops. Oh, my mistake. I did 200R for some reason. 2000, excuse me. So also you want to hit this. If you're doing multiple tests, this is good, because this means it'll start from the beginning every time instead of starting from what it was, and you don't have to manually do this. So there it goes, bending down, picking it up, and putting it down. Hopefully it doesn't explode or anything. Perfect. You can see the completion here as it's going to return to its normal position. Okay, good. So that works now. So if you want to export this, all you have to do is click this little button here. And it's going to load for a second. Uh-oh. Give it a second. Well, I might just cut it here again in case, and then come back when it stops loading. That way, you're not staying on an empty screen. It's loading for forever. Alright, I'll be right back. Alright, so I'm back now. Another reason that it kind of cut off early is because the recording software I'm using only limits to like 15 minutes, so I don't want to get cut off mid-sentence or anything. So you want to click this again. It's a little bit faster now, I guess, once it loads once. So you do right-click, here, load animation. And it's going to be this. You can, the control's still the same, so you can kind of rotate here. So you can see different angles. But frame here, you can use time. So again, start and end time. Frame, you can put 1 works. Make it a little bit faster with like 2 or anything. But you want to just hit play here. So it's going to do that, of course. And put it there. I guess 2's a little fast, huh? Alright, so this one starts it over. So here. There you go. That's just about the speed it was at before anyway. So I was going to put it down there. And good. Alright. So now this is here. It's going to... Oops. Oh, that's right. Yeah, loop once. So you can just put this button here to record. It's going to record at the orientation you set this as. So I just have it here as like like I did in the original one. But, so you want to do is hit record and play. It's a little bit slow. I guess that's just how the recording is, but you can always just speed it up in the video processor or anything. But yeah, this will just finish recording here. Actually, this might be a little too slow. Hold on. Pause it. Just do like 2 and try again here. It should save it. I can just get back to the original one. Like here in the folder where you saved the original thing, so it's just gonna be here. I'll just delete that because I was gonna redo it anyway. Let's try this. It's a little bit faster, but yeah, I guess just when it's recording it's a little bit slower because it has to process it and everything. But yeah, as this finishes, it'll just again save to the folder you have it in. I don't know what type of media you're going to be listening to this on, but in the description I can leave a link to the Google Drive where I have the step files for this, as well as the notepad that I used for all the step functions that I used, and as well as the images for the contact forces here for the box and the arms and all that. But yeah, that's it. This should be working here. Again, you saw the final video, and you can see it again here, kind of at a much slower pace. But yeah, then you can just hit record when you're done again. So yeah, thanks for watching, and I hope you're able to follow this properly, and hope it works for you as well.